K-nearest neighbor classifier in Navure. The K-nearest neighbor (KNN) classifier is a simple and intuitive machine learning algorithm used for classification tasks. It categorizes an input data point based on the majority class of its K-nearest neighbors in the feature space. The choice of K determines the number of neighbors considered for classification. We will illustrate the use of KNN in Navure with the iris dataset, a widely recognized dataset created by British biologist and statistician Sir Ronald A. Fisher in 1936. You can find this dataset in the test data repository, consisting of 5 columns. The iris column contains the names of 3 plant species, while the other 4 columns represent the sepal length, sepal width, petal length, petal width, values for 50 flowers of each species. Once the data file is open, click the Multivariate tab and click the KNN button. Select all numerical variables and drag and drop them into the Numerical Predictors panel. Then drag and drop the iris variable into the Class ID panel. Note that KNN also allows to include categorical predictors. To proceed, click on the blue play button to display output options and additional settings. On the left, you can select the tables to display. On the right, you can specify the tuning parameter, which in this case is the different number of K neighbors the algorithm will try. The CD replicates determine how many times cross-validation is performed. In each cross-validation, the data set is divided into 10 folds, with each fold reserved for testing the classifier to derive performance indices. Press OK button to proceed. Important: when you initiate a classification procedure for the first time, Navure may request firewall permission to access networks. This access is essential as Navure utilizes parallel computing to enhance performance. Please grant the necessary access to ensure proper functionality. The first result is that the best number of neighbors is 7. The first table shows the performance of the classifier. An accuracy of 97% means that 97% of the cases were correctly reclassified. This accuracy is calculated from the average of multiple cross-validation loops and provides a reliable assessment of the classifier's effectiveness. It's important to note that with KNN, all classes in the training data set should be approximately equally represented because the classification decision is based on the majority class of its K-nearest neighbors. The second table is the confusion matrix, shown as the proportion of original cases in each class. As expected for accuracy, all classes were well classified. Only a small fraction of the data was misclassified. The third table summarizes common statistics used in classification problems. Finally, if you go back to the data, a new column named KNN_pred has been added, which contains the predicted classes.